In this discussion, we're going to look at quantitative data analysis. We'll look at levels of numerical information, different types of statistics, including descriptive, correlation, and inferential statistics, and we'll cover a little bit about software. It's important to remember that data collected in research usually falls within two categories: numerical data, which is quantitative analysis, and non-numerical data, which is qualitative analysis. And we'll follow up in a different presentation about qualitative information and qualitative analysis. So let's dive in. Statistics are procedures used to describe, synthesize, analyze, and interpret numerical data. And in general, we'll look at three types: descriptive, correlational, and inferential statistics. So let's talk about the four levels of numerical measurement. There's nominal, ordinal, interval, and ratio. Nominal data is when there's just two categories of an offering. So this would be something like on, off, yes, no. Then we look at ordinal, where we look at a rank order. So we can think about, on a scale of 1 to 10, what would you rank your happiness as? With 1 being very unhappy and 10 being very happy. Now, something you notice is we move from categories to numbers. We also are going to move up again when we look at interval data. So with our ranking from 1 to 10, we're really not sure what the difference between a 5 and a 6 or a 6 and a 7 is. We know generally we're looking at somewhere in the range of 5 being neutral and 7 being somewhat happy, right? But there's no specific distance between those numbers. So as we move to interval data, we're looking at making sure the distances between those units are equal. So I think about something like miles per hour in a vehicle, right? If we're moving from 5 miles per hour to 6 miles per hour, that's the same distance as far as the difference between those is 6 to 7, right? So we're looking at, I traveled 5 miles versus I traveled 6 miles. We increased by 1 and we know an exact distance. Then when we further down the road, we're moving from like 12 to 13 miles per hour or whatever it may be, right? 12 to 13, we know that that 1 mile difference is the same length as the 1 mile previously. Then we can look at ratio data, which is interval data with a true meaningful zero. And so using the miles per hour is a good example, right? If we're standing still, we're not moving, we're at 0 miles per hour. And then if we go from 0 to 1, we have a certain rate that we're moving, and 1 to 2, again, the exact rate, but moving it forward. 2 to 3 is the same, so we're looking at that distance is the same, but we have a true meaningful zero. The zero makes a difference. A way to also look at this would be to think about temperature, right? There's no way we can ever get to zero as far as being a temperature. Absolute zero has never been achieved, right? So there's, we have an idea that it can be theoretically measured, but when you think about Fahrenheit, the zero doesn't really mean anything because we can go below zero. Let's look at a couple of examples here. A hotel manager wants to know which room type patrons most prefer. So the manager counts the number of reservations according to the standard, queen, and king size bed types. So this is ordinal level data. So we obviously have a rate or a rank here, right? So standard, king, and queen are different sizes, but the difference, there's more than one, there's more than two, so there's more than a category. We've got a ranking here, right? And then we don't really know the difference in size or why there's a preference between standard, queen, and king. So the difference between standard and queen may be one thing and a queen and king is another. So it's ordinal data. Let's look at the next one. To be placed in a league, children in a sports program are evaluated on a range from 1 to 10, with 1 representing least ability and 10 most ability. So again, we have ordinal level data because it's ranked. It's not categorical, right? Because we can't put them in some kind of order. But we're not really sure what the difference between 1 and 2 is, or the difference between 7 and 8 are, right? It's not, we can't really tell that by levels of ability. So it's definitely not moving up. So it's ordinal data. Okay, let's take 2 more examples here. A naturalist wants to develop a wildlife plan for a park. He divides the acreage into categories according to use: hunting, fishing, and education. So there is no real ranking here. We're not saying hunting versus fishing versus education is in any type of order. We just have general areas and categories. Because of that, this is nominal level data. There's no ranking. The next one. You want to measure run times for the gold, silver, and bronze medalist in the 4-man bobsled event at the Winter Olympics. So overall, we know run times have a true 0 starting point, right? So when we start the clock, we know we're starting at 0, and we're measuring it until they finish. So we've got a true 0, and that's a good place to understand that we started a stopwatch. And then we're looking at overall ranking them from best to, third best, I guess. Here in this case, it's not best to worst, but we're looking at first, second, and third. So we're ranking them. So, and with time, we know that the differences between 1 second and 2 seconds is the same difference between 3 seconds and 4 seconds. Like that measurement increment is the same. So based on all those, we've got a ranking system. We know that the intervals between the whatever measurement we're using are the same, and then we've got a true 0. So that's ratio data.